So here we are going to talk about a new performance measure called bandwidth delay product. As the name implies, it's the product of the delay with the bandwidth. So the bandwidth delay product defines the number of bits that can fill the link. The number of bits, you have a link, you have a cable, you have Ethernet cable, whatever. If you want to find the number of bits that can fill this link, then you need to find a metric called bandwidth delay product. So imagine here, over here in this figure, you have a link, and the cross section of this link represents the bandwidth, and the length of this link represents the delay, and the volume represents the amount of bits, the number of bits that you can transmit. Volume equal to the cross section multiplied by the length, but in terms of computer networks, we don't have we have bandwidth and we have delay. So the number of, if I give you this, if I give you in the exam, I'll tell you that the bandwidth of a certain link is 1 gigabit per second, and the length, the delay length of this length is 100 millisecond. So tell me how many bits are available in this link. You just multiply them with each other. Or I can tell you the number, the volume, how much is it, and tell you find the delay length, and so on and so forth. So the bandwidth delay product example here, if we want to look at it, you have the first bit, the sender sends the first bit, and then this first bit shifts to the right, and then the second bit comes to the left. Then when a third bit comes, it just shifts the other two bits to the right further, and when fourth bit comes, the same, it shifts them further by 1 bit duration, and so on and so forth. So the number of bits between the sender and receiver is basically the bandwidth delay product, which can be calculated by multiplying the bandwidth with the delay. Let's give an example here. Bandwidth delay product. Consider that the link capacity of a channel is equal to 512 kilobit per second, and the round trip delay time is 1000 millisecond. Round trip time is the time that the packet requires to go forth and back from the transmitter to the receiver. Find the bandwidth delay product. The bandwidth delay product, you just put the bandwidth value, which is 512 kilobit per second, multiplied by 1000 millisecond. You multiply them by each other, you get, of course, you need to do some conversions here. For example, instead of K, you put 1000 bits. K is equal to 1000 bits. Instead of millisecond, you put 10 to minus 3 second. And once you do this calculation, basically the millisecond cancels with the K, then you will be left with 512 multiplied by 1000, and accordingly you will get 512,000 bits. This is the volume. This is the result of the bandwidth delay product. If I ask you to convert this to byte, you just say that 1 byte equal 8 bits. Then if I have 512,000 bits, how many bytes I have? You just do these calculations and you give me this result. Why this is important? The conversions are important, because in the multiple choice question, sometimes I don't give the result in the direct form that you might get by solving the question. So let me give you an example. You might get, for example, the result is 2000 bits. But when you look at the answers, you don't see 2000 bits. You see their conversion in bytes. Or the result might be 100 millisecond, but you don't see, let's say 100 second. But you don't see the results in second, you see it in milli. So these conversions, these tricks, help you answer the question correctly if you know the conversions properly. You need to know K, what's the meaning of K, what's the meaning of millisecond, how to represent it mathematically, what's the meaning of 1 byte, how many. For example, if I ask you what's the length of IB version 6. How many bits one IB version 6 address requires? What's the length of one address of IB version 6? We know IB version 4, 48 bits. IB version 6, what's the length? How many bits to represent one address? 128. 128. Why? Because in IB version 6, we have 8 sections. Each section has 16 bits. So 16 multiplied by 8, you get 128 bits. This is IB version 6. MAC address, how many bits the MAC address? 48 is IB. So you have MAC address, you have IB version 4, IB version 6, and you have this. So IB version 6, what's the length of IB version 6? 128. Okay. What's the length of IB version 4? 32. What's the length of MAC address? 48. This is how, don't confuse them, because we want to make sure everybody. You might see questions related to this in the exam, because now I might not give them in bits, I might give them in byte. So if you don't see bit, don't get confused. I just converted them to byte. Just see the equivalent of this answer in byte. You get it? This is just, I'm giving you an example on why conversions are important. Helps you answer the question if you don't find the direct answer among the choices. You get it? You get it why this is important?